So even though we're not here in person, I still hear the mumblings and the rumblings amongst the students. I can read your thoughts, basically, is what it is. And everybody's basically thinking the same thing. And I'm just willing to say it. You know, you're thinking it, I'm saying it. And you'll be impressed with how well I'm mind reading here. People are thinking, we should have a quiz on water potential so we can show the teacher how well we understand it. You know, it's one thing to keep doing these problems in class and with the lab and everything, but we should really have an assessment. We should have a quiz on it, and then we can demonstrate our learning. Yes, that's right, Sim. I am on point, as usual. Anyway, we got to keep letting people in here. All righty. But, you know, we're not barbarians, so, you know, we'll do a little review, a little practice first with a problem really similar to the quiz, and then we'll give it a try. Fräulein Blöchel, your face tells me everything I need to know. It's just a tiny little square on the screen, but it still tells me volumes. It's very informative. Oh, there's a chat massage. Let's see what it says. What does the massage say? Oh, there's many of them. My mic is broke. Sounds like my bank account. You are so bad at mind reading. Yeah, no, on point, happy birthday. Miss Fangman says you're old. Birthday boy, question mark. Okay, why did you? Yeah, what did you guys get me? Is it in the mail? Because I didn't see anything in my mailbox here. Is it still like getting shipped or what? Coming from Amazon, 1-day delivery? Should I expect it by midnight? Anyway. Clogged arteries, that's nice, thank you. I am the gift, okay, Tyrion Lannister. All right, I'm gonna have to shut the chat off because it's super annoying. No one. All right, that's off. Now that I learned how to do that last time, that was great fun. By the way, since last class, my brain is still kind of a fog. It's all a blur because like the last 15 minutes of class were super weird. And after I read Sophie's like chat post, I think my brain kind of died or something. I don't know what happened there, but like I didn't read it in class. I just saved it and read it afterwards. And then I was like on a Friday afternoon, I was supposed to drive home. I didn't feel safe to drive after reading that. I don't know, it was weird. Anyway, let's take a look at Google Classroom and let's do a practice problem. The one I'd like to do is the one I assigned you. At least I think I assigned you. I can't remember. Like I told you, the brain is a blur. I don't remember anything from last week. I thought I assigned this, but maybe I didn't. It was the lab-related problems. Maybe I didn't assign it since only one person did it. Ouch. Okay, so you guys tell me, did I assign this or not? Did I tell you to do it or did I just forget to say it?
I don't think
I did not. Well, okay. A lot of
You
people
told
are.
us to do our graphs and calculations today.
Yeah, we did the. Did you say the before after one?
Like, you know, in the pivot with the sweet potato celery, you told us to get all that done. And
Okay,
then
yeah,
you
the
said
lab.
that the last question.
That kind of makes sense. Well, that's nice. Then I saved this one. We'll do this one in class right now, and then we'll do a little quiz. All right, cool. Let's check it out. Everybody make a copy of it right away for yourself. I will do the same so I don't mess up the original, which is what I usually do. So I'm going to right away make a copy for myself so I don't do anything horrible here.
Should I unsubmit mine then?
Yeah, absolutely. Is yours, who's the one, was that Lilani or who was that?
Yeah.
I think yours was done perfectly. I think I looked it over. I don't remember. Let me just look. Well, I don't want to look now because everybody can see it, but I think yours was done well. If you want to unsubmit it and check it, that's fine. I mean, whatever. Okay, so let me show you something I probably shouldn't show you. I should make you do these calculations by hand. That's what this was meant to do. I meant to have you do all these calculations by hand or by calculator, where you take the change in mass. In other words, you say, okay, 13 minus 12 is, 1.20. So then you type in the 1.20 here. Okay, and then the percent change in mass is the 1.20 divided by the initial, which is the 12, times 100%. Okay, so that's what you're supposed to do for each one. And then that turns out to be positive because if I'm taking final, a bigger number, minus initial, a smaller number, that's a positive number. And if it's the change, if the percent change in mass is positive, that tells me that the potatoes or apples or whatever this is did what? Increased or decreased if it's positive?
Increased.
I hope you said increased.
Increased.
Okay, perfect. All right, so we're going to do the same thing for each one. And then eventually, so the second one is still positive, but it's much smaller. The third one is going to be negative because we're starting with a, so the final is a smaller number and then minus a bigger number. Players coming in, excellent. And then, so most of these then are going to be negative. Okay, so that's not what I'm going to do though. I'm going to just grab all of these and copy them. Okay, so I'm going to copy these. Then I'm going to check this out. In Classroom, I gave you like a blank spreadsheet. It's actually the exact same one I gave you for the lab. But I put a separate link so it's easier to find. Otherwise, it was just nested in the lab instructions. So that's right here. Water potential and data calculations and graphing. You can use this just to do your calculations instead of doing it all manually. So this is the same one you had before. Let's make a copy of that again. So we're going to use it for a different purpose. We're going to use it to solve a homework problem now instead of the lab, okay? But it's like the calculator is the same. You know what I mean? So I'm going to make a copy quick. You do the same, please. And then here's something I've never been able to figure it out really well. Claire, come on in. Jeez. Anyway, this is something I've never been able to figure out, but when I paste into a cell, it pastes it in the row below. If anybody knows the trick for this, like I don't get it. Like, so I'm going to paste it here in concentration. That's not really where I want it, but I'm going to paste that whole freaking thing and then it puts it in the right place. See, now everything is in the right place. The 0.2, the 0.4, the 0, everything is there, and it does all the calculations and it makes the graph for us. Instantly done. That's going to be really useful on the quiz. You know what I mean? When you have limited time to do this calculation, you don't want to be sitting there subtracting and dividing and all this. So you just paste it in. Everybody try that on yours. Try it. Do try it. What is the concentration inside of the potato cells or apple cells or whatever the hell this is? What is the concentration of solute or sucrose, let's call it? It's not really sucrose, but whatever, solute. What do we look at in this graph?
Where it hits 0.
So where it hits
On
the
the
x-axis, where it's 0 on the y-axis, where it touches the x-axis, that's right here. So to me, that's what concentration? 0.25.
0.5.
I hope you said 0.25. Is that what you said?
Yes.
Claire, still not in. In case you want the other grid lines, you know, we can go to the edit graph and we can put the grid lines in case you need them. Like for this one, we don't need it. It's right on the 0.25, so we don't really need them. But we can go to customize here. We can do the grid lines. We do the minor, oh no, we do the horizontal axis, do 4. And then we get these in there. So I go to horizontal axis and go to the minor count 4. And then you get the nice lines in there. So that's just a little trick. You don't have to do that, but it's makes it easier then to measure the x-intercept. Okay, so now we know it's 0.25. So let's go back to the problem. This one. And I'm gonna now, I'm gonna cheat and do this in Word because I can't draw on here. So I'm just gonna manipulate this real quick here. Oops, that didn't work. Did it work? Oh yeah, maybe it did work. Okay, let me go to Word and then I can draw nicely. So sorry for the delay here. Okay, actually I don't need the graph. Like theoretically I'd be, you know, putting the graph in here and stuff, but I don't. Oops, I gotta just reboot this thing. It's acting stupid. Okay, so normally I'd be putting this in here, you know, like this and finding the X thing or whatever. I already did all that in Excel, or I'm sorry, in Google Sheets. So I knew it was 0.25 molar. Okay, so that spot was 0.25 molar. So now I'm gonna do my calculation. So I know the inside of the cell is 0.25 molar. So then I can figure out the inside solute potential in the cell is going to be negative ICRT, and that's going to be negative, it's 1 for sucrose. In your lab, it's 2 for salt, okay? C was 0.25, R was 0.0831, and then just the only thing we're missing is temperature, so let's go back up. Oh, I don't have it here, but temperature was what?
Celsius.
Say it nice and loud.
20.
Thank you. So 20 plus
Celsius.
273, right? Do you remember the 273 thing, you guys? Do you remember that Kelvin thing? Everybody? You could just say yes on the mic and that would make me so happy.
Yes.
Yeah.
Claire, only 7 tries. I thought of a new motivational trick to get you to join class sooner, Claire, and here's how it goes. Each time you fail to enter after I click admit, your grade goes down by 1. So that way it'll motivate you to just enter right away.
That's
Isn't that a good idea? It's I think
wish.
it's great ideas.
Oh, my mom's already upset enough. Don't do that, please.
Oh,
Please
I thought it
don't
was
do
a really
that.
good idea. Anyway, okay, so plug that in, and where's my calculator? Somebody's got this figured out already.
6.08.
Think about your answer and make sure it's 100% correct. The number sounds good.
Negative.
Thank you, very good. Oh, I typed the wrong thing in here. Okay, I'm going to trust you. Is he right? I typed the wrong thing in my calculator. Negative 6 point.
I'm pretty sure it would round to a negative 6.09.
Oh, that I'm not too worried about, but okay, let's do this. 09 or 08, I don't care. You know, if you're off by 0.01, it doesn't matter. Okay, so somebody, okay, thank you for typing that in there. Excellent. Okay, so that's bars. And if you guys are like, oh, how did you get bars? Well, then we can put all the units in here and cancel them all out if you want to. We can do all that, the liters, kelvins, moles, bars, and all that. And they all cancel out except for the bars. And bars are just a unit of pressure, how hard the pressure is pushing, that's all, or pulling in this case. So, all right, so then that's that. That's that whole first page of that problem, I think. I think that's all that's asking. Let me just check. Yeah, calculate the solute potential of Gudrun's apple cells. Who comes up with these names? Gudrun? Germans have some weird names, let me tell you. Dagmar. You ever hear of Ute? That's a girl's name in Germany, Ute. That sounds really lovely, doesn't it? Anyway. Okay, let me get rid of this garbage here. And now we got to go to the next page. So on the next page, this is, so anyway, by the way, when I give this question or a question like this on a test or on a quiz, everybody gets this right. Like everybody gets this. This is like easy. They figure out, okay, here's the place where X, where it hits X, and that's 0.25, and they can do the negative I equals CRT. Just leave it turned off. Don't open it up, just close it. All right. Can you show the graph? Yeah, I can show the graph here. Here's the graph. Okay, so the graph is right here at 0.25 is where it intersects. That's how we got that. All right. So, so that first page, everybody gets that. It's the other one. What other one? Like this one? This one? Talk to me in voice, that's easier. What's there to show?
That graph.
Well, I didn't draw it correctly. I mean, it was probably more like this if it was set up. Oh, it was probably more like this or something. I don't know. Do you know what I mean? You want me to like fill it all in or something? Like all the axes?
No, I just wanted to see where you're going with it, but that's fine.
Well, this graph is in lieu of this, like we did this graph here instead. This is easier because it did the graph for us. So we don't have to do this one then. It's the same thing, like this would be the manually plotted one that you did by hand. This is the cheating one that just Google Sheets did for us. So we can just use this because it's way less work. So on the quiz, I want you to do it the Google Sheets way because it's super fast. Are we good, Paige? I can actually see you. I don't even know where you are. I have too many people on the screen. All right. Okay. Okay. So then the next page is where kids mess up. And that's where like, I've had years where like a third of the class will get it wrong. And it kind of hurts my feelings because I do such a good job teaching this and the kids just, I don't know. So this year I'd like you guys to really don't let me down, This will be the year where everybody gets it, right? Yes. All right. So let's give it a try. All right. Oh, I'm in the wrong place. Sorry. Where am I? So now I need to do this. I really need to open this in. Well, I'll just do a screen snip again. What the heck? All right, sorry that I'm fumbling here, but good teacher would have had all this set up. But what? Didn't I just paste this? There it is. Okay, I don't know why it didn't go there right away. Okay, so now you got to read the instructions really carefully because, and that's really what the kids messed up on in years past is they didn't read these instructions. So let's read them carefully because I'm going to give you the same gosh darn problem on a test and I'm going to give you the same one on this quiz in just a minute. So hopefully you'll get lots of practice. So explain the events in trial 1 Okay, so trial 1 was pure water. You go back to the thing here, and you see that trial 1 was pure water. Oh, I'm in the wrong place here. You see that trial 1, pure water, 0. That's, solute potential 0. Okay, so let's go to that. So then we know that the solute potential of the water is 0. So we can put that in there right away, bars. Okay, well, that's easy. Okay, solute potential of the apple cell, then kids are like, oh, I'm just going to make something up. It's like -3. No, 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 no. I don't want you to make it up. I want you to use the one from the other page. This is talking about the question 1, the other side of the sheet. Okay, so what was the solute potential there? Well, it was -6.08. So we're going to use the -6.08 here. Okay, so this is -6.08. We just figured that out. I don't care if you don't write the bars. I know chemistry teachers would freak out if you don't use units, but since it's always bars for us, like it's not like it matters, okay? That much. Don't tell the chem teachers because they're gonna get mad at me. And I do care about units. It's just that in this case, we just don't need to. So the solute potential on the inside, oh, I'm sorry, the water potential on the inside is -5.08. Everybody clear? Okay, so now I'd like you guys to do trial 4. So once again, we're not just making stuff up here. We're not just making stuff up here. We actually know the exact amount. We can calculate it. Like we know the apple cell already because we just did that on the page before. It's this. So we know that. But the sucrose solution for trial 4, go look at trial 4. What was the concentration? You can use that and do -I equals CR, solute potential is -I CRT and figure out the solute potential of that solution. So go ahead and do that and then tell me which way the water is going to flow. Actually, we haven't figured out which way the water is going to flow here yet. Let's do that real quick. So it's -5 over here and it's 1 over here. Which way is the water going to flow? In or out?
In.
In is correct. It's going to flow in. All right, do the other one now. All right, you guys should be done with that. Because pretty simple calculation here. So I'm going through it now. I'm saying that my solute potential on the outside, I need the concentration of sucrose. So I'm going to go back to my first page and I'm going to look, okay, trial 4 was 0.6. So that's where I get that information that I need. Everybody with me? A common mistake that kids make is they go over here and they say, oh, I went and looked it up. The solute potential is 0.6. No, that's the concentration of sucrose. The solute potential is in bars. You got to do the negative ICRT thing. Okay, so that's not how that works. We don't put the concentration there. We use the concentration to calculate the solute potential. So that's why I left this space here to show the work. We're going to figure out this solute potential right here down below. Let's figure it out. It's negative ICRT, negative 1, 0.6. We got that from the first page. That's trial 4. 0.0831, that's the pressure constant. 293 is the temperature in Kelvin. And we get, I don't actually know what we get. You can type it in the chat if you have the answer. No one type. Oh, somebody did type it. Thank you, Elena. Thank you, Ellie. Negative 14.61 bars. So now the next part would then be, so we're not done yet, so we can put that in here. Negative 14.61. And then we figure out the outside water potential, which is the pressure plus the solute. So it's negative 13.61. Okay. Inside, it's negative 5. Outside, it's negative 13. Which one is greater? Well, the inside is greater than the outside, so therefore the water flows in or out?
Out.
Okay, and then the reason, I accidentally wrote the reason over here on the other one, but the reason would be because the inside is greater than outside solute potential at negative, what was it, 13.6. Negative 5 is greater than negative 13. That's the reason. That's our justification. So on a like an AP test, if they say, which way does the water flow? And you say out, okay, good, you got that right. Now justify your answer. So 1 point for out, good, you got that point. The other point is justifying your answer. In other words, water potential on the inside at negative 5 is greater than the water potential on the outside at negative 13. Water flows from higher water potential to lower water potential. Water flows from higher water potential to lower water potential. Everybody with me? When I first started talking about this stuff, I said the stuff we're going to do gets kind of hard. Was I right or was I wrong? Okay, almost everybody's doing this, that's pretty hopeful. And people are, oh, means I was right. It is hard, or I don't know. I don't actually, maybe I should have phrased the question differently because I don't even know what your answers mean. Okay, anyway, I think this stuff is challenging. Like I gotta have my brain turned on when I do these problems. Like I gotta think a little bit. Like, okay, which way does it go? But I gotta think. It doesn't just like automatically come to me. So if I have to think that hard, I'm thinking it must be hard for you too, because I don't know. I've had more experience. It's not necessarily hard, but complicated. Yeah, lots of little parts to it, and it's easy to forget, like the negative. It's easy to accidentally take the concentration. Oh, I'm going to take the 0.25 molar. I'm going to throw that in there. No. We need the pressure, the psi, the water potential. That's what we need. So we got to take the molar concentration and calculate the water potential, and then we're good to go. All right. Oh my goodness. Oh my goodness. Let's see if we got this covered. Yes, we do. We have the whole thing done. Well, I just did the whole homework for you. I'm going to have to redo this with different numbers so you can actually do it for homework.
Wait,
So I will give you a different.
I have to do it because I did it before we talked about it. So do I still have to do the new one?
I'll tell you what, I'll make you a deal that's fair to you. I will give you the one you did back. So then I will not take that from you, and then you can do the new one, and then everybody's the same. How about that? So then you still have an extra one left over for the
Okay.
future. You could sell it on eBay. Anyway, thanks for asking though, Leilani. All right, I'm gonna be quiet for about 20 seconds here and give you guys a chance to contemplate if you want to ask something or if you're express your feelings or whatever. All right, well, you know what time it is. Boys and girls, you know what time it is. It's quiz time. Everybody's favorite time. Let's go to the Google Classroom and, oh, I don't have the quiz active. I'm gonna make it active. It is a Google form. The first two questions are the ones we just did basically, but different numbers. You may use your Google Sheet to do all the calculations for you, except for the, obviously for the solute potential one that you have to do yourself. But all the subtractions and the percent change and all that, the Google Sheet will do for you. And then the rest of the questions are like just like about diffusion and like fish in the ocean and stuff like that, you know, like stuff that you should know from my lessons. You can use your notes if you'd like. Use whatever resources you have, just don't talk to each other. I feel like I don't understand it. Well, that's what the quiz is going to tell us, okay? The quiz will let us know that. It'll tell us, do you get it or not? I'm not going to count this quiz for your grade. So this is low stress. This is just for fun, okay? It's just fun. I mean, don't get a 0. It looks bad, but it's not going to hurt your grade. Praying for me and everyone else besides Leilani. Leilani's in good shape. You better not mess this up, Leilani. Let me tell you something. If you mess this up, oh, they'll, ooh. Gonna make me a liar. Okay, quiz is going live. Here goes. It's only 6 questions. All right, you should see the update in your Google Classroom hopefully soon. And have fun. Cameras on during the quiz, by the way. Everybody camera on during the quiz. Okay, Gruber, let's go.